welcome to my YouTube channel. In this video, we're going to cover the three different methods of factorizing binomials. A binomial is an expression with two terms. An example of binomial is 4x plus 2, a minus 4b, 25x plus 32xy. Most of the students used to confuse themselves with expressions and also equations. An expression doesn't have an equal sign, and equation have an equal sign. So we're going to look at factorizing the binomials. Factorizing is to split an expression into the product of two or more brackets, meaning that you are expected to have two or more brackets after factorizing. So we have three methods of factorizing: the use of a common factor, difference of two squares, lastly the different sum of two cubes. So in this method, we take out what is common amongst terms and we put it outside the bracket. So we're going to start by solving for x plus 2. In this problem, I'm going to take 2 as the highest common factor because 2 is a factor of 4 and a factor of 2. So it can be divided by both. 4 divided by open bracket, 4 divided by 2 is 2x plus 2 divided by 2 is 1. That's the answer. The second example is 6x squared plus 3x. So in this case, the highest common factor here is going to be 3x because 6x squared can be divisible by 3x, and also 3x can be divisible by 3x, which is our answer is going to be 1. So here we're going to take out the 3x, put it in a bracket, open a new bracket, then 6x squared divided by 3x is equals to 2x. Then 3x divided by 3x gives us what? It gives us 1. Then this is your answer. Then now we're going to look at the difference of two squares. This is used when we have perfect square numbers. Perfect square numbers such as 4, 9, 25, and 36. What are perfect square numbers? A perfect square number is a number that can be presented by another number to the power of 2. For example, 4 can be represented by 2 to the power 2. 9 can be represented by 3 to the power 2. 25 can be represented by 5 to the power 2. And 36 can be represented by 6 to the power 2. So our example for difference of two squares is going to be 4x squared minus 64. So here we have to start by opening two brackets. Then the square root of the square root of 64 is going to be 8. Then here 4x cubed divided by 2x is going to give us 2x. Then our negative 64 divided by 8 is going to give us. Then on our third term, we have to multiply these two terms. 2 times 8 is going to give us 16x. Then here we're going to take the sign, which is going to be negative sign. Then on this sign, we take the opposite of negative sign, which is positive sign. Then here it's always positive. So our answer here is 2x minus 8 is 2x minus 8, 2x plus 16x plus 8. This is our answer. Our second example is going to be 3x squared minus 108. So what you have to do here first, as we all know that 3 is not a perfect number, we have to check that is 108 divisible by 3. Of course, it is divisible by 3. So we take out 3 as a common factor here. We're going to be left with x squared minus 108 divided by 3. 108 divided by 3 is give us 36. Then here is 36. But here we're not done. As you can see here, 36 is a perfect number. So what are we going to do? We're going to open two brackets. So it's going to be x. Square root of 36 is what? Is 6. Then here is x squared divided by x is x. Then 36 divided by 6 is 6. Then 6 times x is 6x. Our answer, our negative sign here. Then here it's always opposite to this sign, which means it's going to be positive sign. Then here it's always positive. This is our answer. So now we're going to focus on the difference of sums of two cubes. This method is used when we're dealing with perfect cubes. An example of perfect cube is 27, 8, 125, and also 27x cube. A perfect cube number is a number that can be presented by another number to the power of 3. So 27 can be presented by 3 to the power 3. 8 can be represented by 2 to the power 3. 125 can be represented by 5 to the power 3. And also 27x cubed can be represented by 3x close bracket to the power 3. So our example here is going to be x cubed plus 27. So in this case, we're going to have two brackets. On our two brackets, the first term of the first bracket, it is the cube root of x cubed. X cubed, the cube root of x cubed is x. Then our second term on our first bracket, it is the cube root of 27, of which is 3. Then here, for this first term on the second bracket, you say x cubed divided by x, it gives us x squared. And for this third term on the second bracket, you say 27 divided by 3 is going to give us 9. Then the second term, the middle term of the second bracket, you multiply both terms on the first bracket. Then when it comes to sign, the first bracket will also take the sign of the expression. Then the first sign of the second bracket is going to be the opposite of the sign of the expression, of which here is negative. Then here it's always positive. Then our second example for difference of sums of 3 cubes is x cubed minus y cubed. So here we're also going to open two brackets. The first term of the first bracket is going to be the cube root of x cubed, which is x. The cube root of y3 is y. Then here, x cubed divided by x is x squared. Then y cubed divided by y is y squared. Then here, y times y, it gives me xy. Then when it comes to the sign, the first bracket takes the sign of the expression, negative. Then the first sign of the second bracket, it opposites the sign of the expression, of which here is positive. Then here it's always positive.